Welcome to Statistically Speaking with Dr. Elbayumi, where we turn numbers into knowledge. Hello, everyone, and welcome back to our course on data privacy, ethics, and security. I'm very glad you're joining me today. In this video, we are going to talk about a topic that sits at the heart of modern data science, research, and decision-making: issues with data exploration, analysis, and dissemination. In simple words, we are going to talk about what can go wrong when we explore data, analyze it, and share it with others, and more importantly, how we can do better. As someone who has been teaching and doing research for over 25 years, I can tell you this: most ethical problems in data do not start with bad intentions. They start with small, careless decisions that grow into serious consequences. So today, I want you to think not only as analysts, but as responsible professionals and ethical leaders. Let's begin. Let me start with a simple question. Why should we care so much about how we explore, analyze, and share data? After all, isn't data supposed to help us? Yes, it is. But data also has power. It influences who gets hired, who gets loans, who gets medical treatment, who gets monitored, who gets promoted, who gets denied opportunities. Every time you work with data, you are shaping decisions that affect real human lives. So this is not just about numbers. This is about fairness, trust, justice, responsibility. And that is why this topic is so important. Let's begin with the first stage: data exploration. This is where we look at the data, create plots, compute summary statistics, check distributions, identify outliers, look for patterns. Many people think exploration is harmless. They say, I'm just looking, but even looking can create problems. One major issue is privacy exposure. Imagine you are analyzing hospital data. You open a data set and you see names, dates of birth, zip codes, diagnoses. Even if you never publish this information, you have already been exposed to sensitive personal data. This creates risk. What if your laptop gets stolen, your file gets leaked, you share your screen in a meeting, you store it on an unsecured cloud drive? Suddenly, private information is no longer private. I have seen cases where students accidentally uploaded raw datasets to public repositories, not intentionally, just carelessly, but the damage was real. So lesson number one: exploration must be done in secure environments with protected data. Another issue is re-identification. You might think, I removed names, it's anonymous. But is it? Let me give you an example. Suppose a data set contains age, gender, zip code, occupation. With just these four variables, many people can be uniquely identified. Researchers have shown that combining a few variables can re-identify individuals with high accuracy. So even anonymous data can become identifiable. This is why we must be careful with small groups, rare conditions, extreme values. Outliers are interesting statistically, but dangerous ethically. Now let's talk about a psychological issue: confirmation bias. This happens when we subconsciously look for patterns that support what we already believe. For example, suppose you believe students who study more hours perform better. You start exploring the data. What do you focus on? You focus on plots that show a positive trend. You ignore plots that show weak relationships. You ignore confounding variables. You don't do this intentionally. It happens naturally. We are human, so exploration can become biased. This leads to selective reporting, misleading conclusions, overconfidence. Good scientists fight their own biases. They ask, what evidence contradicts my beliefs? Another major problem is data dredging, also called p-hacking, phishing, data snooping. This happens when you explore data again and again until you find something significant. You try many variables, many models, many transformations, many subgroups. Eventually, something becomes significant by chance. Then you report only that. This inflates false discoveries. It looks scientific, but it's misleading. Ethically, this is very dangerous because it creates false knowledge. Now let's move to the second stage: data analysis. This is where we build models, test hypotheses, train algorithms, make predictions, estimate effects. Here, the risks become even bigger. Let me be very clear. No algorithm is better than its data. If your data is biased, your results will be biased. Example: suppose you train a hiring algorithm using past hiring data, but historically, certain groups were underrepresented. Certain groups were discriminated against. What will your model learn? It will learn discrimination, not because it is evil, but because it is copying history. So, algorithmic bias is often historical bias. Examples include hiring systems, credit scoring, facial recognition, insurance pricing, risk assessment. This is one of the biggest ethical challenges today. Another issue is opacity. Many modern models are black boxes. Deep learning, ensemble methods, complex pipelines. They give predictions, but not explanations. So we cannot answer, why was this person rejected? Why was this patient flagged? Why was this student classified as at risk? This creates ethical problems. People deserve explanations when decisions affect their lives. Because the algorithm said so is not acceptable. Overfitting is usually taught as a technical issue, but it is also an ethical issue. When you overfit, you create overconfident predictions, false precision, misleading certainty. Then decision makers trust results that are unreliable. Imagine a medical model that overfits. It may recommend wrong treatments. That is not just bad statistics, that is dangerous. Let's talk about p-values. Many ethical problems come from misusing them. People say, p-value is less than 0.05, therefore it's true. No. Statistical significance is not practical importance. A tiny effect can be statistically significant in big data, but meaningless in real life. If you exaggerate significance, you mislead. This affects policy, medicine, business, education. We must interpret results responsibly. Every analysis has uncertainty, but many reports hide it. They give point estimates without confidence intervals, predictions without margins of error, forecasts without risk assessment. This creates false certainty. Ethically, that is dishonest. We must communicate uncertainty. Now let's move to the final stage, data dissemination. This is where we publish papers, share reports, release datasets, create dashboards, present findings. This is where the public sees your work, and this is where harm can spread fastest. Even if you protected data during analysis, you can still violate privacy during dissemination. Examples: publishing detailed case studies, showing rare combinations, sharing raw datasets, posting screenshots. I have seen papers where individuals could be identified, not intentionally, but through careless details. Once published, it's permanent. You cannot take it back. Visualizations are powerful, but they can deceive. Examples: truncated axes, distorted scales, cherry-picked ranges, misleading colors, overcrowded plots. These can exaggerate effects, sometimes intentionally, sometimes unintentionally. Either way, they misinform. Ethical visualization means honest scales, clear labels, full context, no manipulation. This is very common. Researchers report positive results, significant findings, interesting patterns. They hide null results, failures, weak relationships. This creates publication bias. It distorts scientific knowledge, it wastes resources, it misleads policy, it slows progress. Ethically, negative results matter. Once you release data or reports, you lose control. Media may oversimplify, politicians may misuse, companies may exploit. Example: a correlation is reported, the public thinks it is causation, a risk is reported, people panic, so we must communicate carefully. We must explain limitations, clarify assumptions, avoid sensationalism. Open data is valuable. It promotes transparency, reproducibility, collaboration, but it also increases risk. If data is too open, privacy is threatened. Vulnerable groups are exposed. Misuse becomes easier, so we must balance openness and protection. There is no simple rule. It requires judgment. Let me give you a few practical examples. Example 1. Health data hospitals collect massive data, used for research, AI diagnostics, policy planning. But if leaked, patients suffer stigma, insurance, discrimination, emotional harm. Even anonymized data can be re-identified, so health data requires extreme care. Example 2. Student data universities collect, grades, attendance, behavior logs, online activity, used for early warning systems, advising retention, but misuse can label students unfairly, create self-fulfilling prophecies, reduce opportunities. Ethics is critical here. Example 3. Social media. Data companies analyze likes, clicks, messages, location used for, targeted ads, political messaging, behavioral prediction, but this can manipulate behavior. People become products. That raises serious ethical concerns. So what can we do? Let me summarize key principles. 1. Data minimization. Collect only what you need. More data is not always better. Less data means less risk. 2. Informed consent. People should know what is collected, why, how it is used, who accesses it. Consent must be meaningful, not hidden in 50-page terms. 3. Secure infrastructure use, encryption access control. Secure servers, regular audits. Security is part of ethics. 4. Bias auditing. Regularly test models for demographic bias, performance gaps, disparate impact, fix problems early. 5. Transparency. Document data sources, cleaning steps, assumptions, limitations, open methods, build trust. 6. Ethics review. Use institutional review boards, ethics committees, peer review, independent oversight matters. 7. Responsible communication. When you publish, be honest, be clear, be cautious, be humble, do not oversell. Let me speak to you directly now. You are not just learning tools, you are becoming professionals. Your future work will shape policies, technologies, institutions, lives. Ethics is not an extra topic. It is part of your identity. Every data set you touch carries responsibility. Every model you build carries consequences. Every report you write carries influence. So ask yourself, who might be harmed? Who benefits? Who is excluded? Who decides? That is ethical thinking. Let me conclude with this. Data is one of the most powerful forces in modern society. It can improve lives, reduce inequality, advance science, but it can also exploit, discriminate, manipulate, harm. The difference is not technology, the difference is people, people like you. So I encourage you, be skilled, be critical, be honest, be ethical, because the future of data depends on it. If you found this video helpful, don't forget to like, subscribe, and click the bell to stay updated on all things data and statistics. Thanks for watching.